Hello, everyone, and welcome to our webinar, Cost-Effective Web Hosting on AWS Graviton. My name is Ilanit, and I'm the VP Marketing for To Be Cloud. Just a quick few household rules before we start. So we at To Be Cloud strive to provide a professional and respectful environment and extend it to pretty much everything that we do. Throughout this webinar, you are more than welcome to share your questions and observations in the chat. Just please be mindful of your language. This webinar is being recorded. You won't be shown on screen, and of course, feel free to share your questions and note, and they'll be answered as we receive it. Quickly about us, To Be Cloud, we are a global AWS financial partner. We serve over 400 startups and digital native companies worldwide. We provide 24/7 engineer-to-engineer support with a 10 minutes average first response time. We provide cloud consulting on DevOps and infrastructure, cost optimizations, and additional other services. If you want to get in touch with us and see how we can help you master your AWS cloud, feel free to scan this and leave us a note. So now, without further ado, I want to transfer the mic to our first speaker, Shelby.
Hi, thanks for having me. All right. Hi, everyone. My name is Shelby Salling. I'm an efficient compute specialist here at AWS. That covers Graviton, Spot, auto-scaling groups, savings plans, essentially how we can help our customers scale without sacrificing performance while maintaining the best price performance compute options. So today, I'm going to go over Amazon EC2 instances powered by Graviton processors. AWS has the broadest and deepest range of choices for compute platform. We have families of instances designed for virtually any workload, whether you want to optimize for raw CPU cycles, memory per CPU, even high I/O storage and powerful GPUs. Each of those instance families can be further customized, including with choice of processor, type of storage, ultra high-speed networking, and even bare metal options. If you add in other options such as Amazon Elastic Block Store, we have over 800 distinct instance types, so it gives our customers the most choice and flexibility when it comes to compute. We also have the broadest choice of processors, including a full range of Intel Xeon processors. We leverage the EPYC processors from AMD. Those are powerful but cost-effective options for x86-based workloads. But today we're going to focus on our ARM64 ecosystem, specifically on our AWS Graviton family of processors. So Graviton is our in-house processor, allows Amazon to own the entire silicon stack. We built these ARM-based processors in-house to deliver the best price performance in Amazon EC2 for a broader range of workloads. It costs up to 20% less than comparable EC2 instances based on our on-demand pricing. And another highlight is it uses up to 60% less energy than comparable EC2 instances. So I'm going to go through a little bit of history before I go through the benefits of Graviton. So today we have 4 generations of processors, starting back in 2018 with the release of our Graviton 1 processors. So when we introduced the first processor, we already saw an up to 45% cost reduction than comparable instances x86-based for scale-out workloads. A year later, we released Graviton 2, and building off of that, there was up to 40% better price performance than comparable instances. Graviton 3 came out a few years later, and that building on Graviton 2's success, offers up to 25% better compute performance and up to 2 times the floating point performance of Graviton 2. And lastly, at last year's reInvent, we announced the Graviton 4 chip, which has up to 30% better compute performance, 50% more cores, and 75% more memory bandwidth than Graviton 3. And today our R8G instances are live on those. So across all 4 of these processors, today AWS offers more than 150 different Graviton-powered EC2 instance types globally at scale. We built more than 2 million Graviton processors, and we have over 60,000 customers, including our top EC2 customers. They all use Graviton-based instances to achieve the best price performance for their applications. So these customers include customers like Datadog, DirecTV, Formula One, Nielsen, Pinterest, Snowflake, etc. I'll get a little bit more into the customer specifics later, but I'm going to talk a little bit more about Graviton first. So what kind of workloads run best on Graviton? Well, here's a high-level overview. There's a broad applicability, but these are, where we see the most success. Web and gaming servers, which is what we're highlighting today, but also open source databases, high-performance computing, in-memory caches, media encoding, electronic design automation, machine learning analytics, and containerized applications and microservices. Here's a visual of the different instance types that are available across Graviton processors today. We've got general purpose, compute optimized, memory optimized. You've got the G5Gs for accelerated computing and the HPC7Gs for the high performance computing optimized instances, and then the storage optimized on our I series. Although we're talking about EC2, I didn't want to leave out managed services. We extend the Graviton price performance to our managed services, and a lot of times now most of these automatically launch on Graviton. But if you're running any single one of these managed services, Graviton is the best price performance option as well, not just for EC2. So I'd say the vast majority of our EC2 customers actually start by migrating at least one managed service. And some of our top adopted on Graviton are RDS, Elasticache, and OpenSearch. We're going to talk a little bit more about the how later, but I wanted to give a high-level overview because the number one question that I get is around ease of adoption, and said, okay, all of this sounds great, but how easy is it going to be for me and my specific infrastructure and my specific stack to migrate to Graviton? So this is a bit of a way that we start to make sense of the world. Obviously, it's going to be workload dependent, but for the most part, the shorthand is the more up to date, the better. So you could tell on top, seamless adoption comes from, like I mentioned, those managed services. EMR typically just works, and then it kind of goes down in terms of involvement from there. The only highlight that I'd like to share is in terms of non-applicability is Windows workloads, with the exception of migrating to Linux and .NET Core on ARM64, just due to licensing restrictions from Microsoft. But other than that, like I mentioned, broad workload applicability, a ton of instance types and flexibility. So there's a lot of opportunity here to be able to run your workloads on Graviton. A couple highlights of our most recent processors. So like I said, Graviton 3 was released a few years ago. So the Graviton 2 processors were designed to push the price performance for a broad range of workloads for our customers. We have thousands of customers who have realized significant price performance with Graviton 2, but the latest generation of Graviton 3, like I mentioned earlier, builds off of the progress we made with Graviton 2. So it actually provides up to 25% better compute performance over Graviton 2 processors, providing the best price performance with the exception of the RSGs well, I guess that was memory optimized, but for Graviton 3, that's going to be your compute intensive workloads. So high performance computing, like gaming, like I mentioned, that video encoding, CPU based machine learning inference. These instances provide, like I said, 25% better performance compared to 6th generation Graviton 2 based C6G instances and the C7G. So I'm referring to the C7Gs on Graviton 3. And when we talk about Graviton 4, that was the belle of the ball, if you will, for last year at reInvent. These ones were released just going GA earlier this year. Those R8G instances, and again, similar to Graviton 3 as compared to Graviton 2, Graviton 4 as compared to Graviton 3 provides up to 30% better compute performance, 50% more cores, and 75% more memory bandwidth than current Graviton 3 processors. So this delivers the best price performance and energy efficiency for a broad range of workloads, like I mentioned before, running on EC2. So I'm going to show this one more time just to give an overview. Again, available across regions globally. This is an aggregate list of instance types that run across the processors. So clearly, one takeaway is a lot of flexibility as we innovate and release new processor types and instances that run on those processors. So I'm gonna let some of my co-hosts talk a little bit more about the how of adoption, but I want to highlight how our customers are using Graviton today. So I'm going to highlight a couple of use cases and case studies and talk about how customers find success, even our own customers find success in-house leveraging Graviton processors. First, I'd like to highlight, just the broader range of customers. Like I mentioned, over 60,000 today. In Q2 24, more than 94% of the top 1,000 largest customers of Amazon EC2 have used Graviton-based EC2 instances. So in the last, 5-6 years, that's pretty big in terms of growth of adoption. Some highlights, and I'll get into one of these case studies in more detail. Nextroll said that they've seen about 15% more requests handled by C7G instances and up to 40% better latency compared to Graviton 2-based C6G instances. Company Sprinkler improves performance by 20% and reduced cost by 25% for machine learning inference on Graviton 3. And Stripe measured up to 50% query performance improvement and 10 to 15% reduced error rate, so fewer timeouts on payment processing. I actually have a Stripe highlight, so we'll get into that in further detail in just a minute. But before I do that, we definitely drink our own champagne. So for those of you who have kept up with some of Jeff Barr's blogs, he always highlights, the kind of Prime Day recap in terms of our own compute. And Graviton's always, for the last few years, the star of the show there, right? So in 2021, we had 12 core retail services, 3 region cluster composed of over 53,000 Graviton 2-based C6G instances. Moving into 2022, we increased the adoption of Graviton 2 internally, creating more efficiencies, and overall server footprint was only 7% larger than Cyber Monday in 2021. In 2023, tens of millions of normalized Graviton instances to power over 2,600 services. But the real highlight is 2024. We experienced hypergrowth. So there's over 250,000 Graviton chips powering more than 5,800 distinct Amazon.com services. So definitely, I think, is a show of our own confidence in our own service in running, one of the biggest days in Amazon e-commerce on Graviton. All right, I have a few customer highlights. I'm going to go through across a few different industries. The first one is Stripe. If you're not familiar, Stripe is a payment processing company. They process over 800 billion in payments over 45 countries worldwide as of 2021. So I'm sure that number is even higher now. Stripe basically powers the GDP of the internet. They simplify online transactions for all types of customers and support 135 different currencies. So some of the challenges, right? As customers were abruptly shifting spending patterns to online during the pandemic, Stripe capitalized on AWS's elasticity to scale with increased payment volume. Stripe's EC2 footprint grew 5 times during the 2 years of the pandemic to accommodate that growth. They embarked on a journey to adopt Graviton to contain costs while improving their customer experience, and they really lacked a way to kind of scale adoption across hundreds of workloads. So they went ahead and built automation to deploy multi-architecture pipelines, enabling teams to seamlessly build and deploy both x86 and Graviton EC2 and container images, simplifying the task for their application teams. They performed tests comparing Graviton performance using Stripe-specific workloads, and they developed automation to enable self-service adoption model to scale Graviton adoption. So the results, I know I mentioned a little bit in the last slide. More detail is they ended up reducing query latency by up to 50%. They improved end user experience by reducing query timeouts by 15% with no increase in costs. They experienced 10 million in savings in the first 12 months, and they accelerated the path to savings by an estimated 12 months. And by doing all this work, they actually also engaged with ProServe, which freed developers to focus on innovation. So in partnership, we've got a couple of quotes. With Graviton, we strive to optimize compute costs with minimal burden to the development teams, which is the head of core compute. And then the CTO at Stripe said that they couldn't run without AWS, and they wouldn't want to. AWS is the customer's first choice, and the platform gives them enormous developer leverage. All right, another highlight, hopefully a familiar face, Pinterest. So if you haven't heard of Pinterest, they're a visual discovery platform available in over 40 languages with more than 500 million monthly active users exploring billions of ideas and inspiring content. I don't know about you guys. I definitely have a Pinterest board full of different recipes. Every time I'm not feeling inspired for the week in the kitchen, I pop on Pinterest and I try to get inspired for something new in the kitchen. So Pinterest's mission is to inspire people through its applications. For me, in my case, to inspire my dinner journey, and it requires an extensive AI-powered infrastructure. So to improve their infrastructure's ROI while meeting sustainability goals, which they're very passionate about at Pinterest, they looked at AWS Graviton for its price performance and energy efficiency benefits. They've been using EC2 for about 10 years. So Pinterest has run on Amazon for a long time. And when AWS announced the Graviton-based instances in 2019, when they went GA, and after ROI studies, they fully invested in a migration program in 2021. They did benchmarking and testing for public workloads in 2022 and started doing deployments for various workloads. And by June 2024, the team migrated more than 25% of their compute infrastructure over to Graviton. So again, a lot of that already ran on AWS, but over 25% specifically to Graviton. So they identified an important workload consisting of thousands of instances that serve Pinterest API, which is central to every aspect of Pinterest product and business and responds to billions of API requests every day, and works alongside AWS team to benchmark the positive impact of Graviton-based instances on improving the efficiency of this workload. This effort was part of their cost efficiency program, aligning with sustainability. They complemented that by renewable energy transitions and resource consumption reduction. They ended up seeing a 47% reduction in those targeted workload costs. So again, that's for a quarter of their compute estate. So a pretty big impact when you think about the scale of Pinterest. 62%, lower carbon emissions per API request, and 38% reduction in compute resources for an important workload. So being able to downsize that fleet also improved costs as well. All right. Hopefully, again, another familiar face. This one is exciting too. So Epic Games, and specifically Fortnite, right? So Epic Games is the interactive entertainment company behind Fortnite. It's one of the world's most popular video games. It says 400 million players here, but I think the number is now 650 million. So pardon me for not having that updated. There's a ton of new players onboarding every day. So founded in 1991, they really transformed in gaming with the release of their Unreal Engine. So they have Fortnite, which is one of the largest online multiplayer games, if not the largest. But their Unreal Engine is a 3D creation engine powering hundreds of games and game development now used across industries such as automotive, film, television, and simulation. So it's game development, it's film creation, etc. So a lot of really cool work that they're doing that are powered by Graviton processors. So the challenges and opportunities. So like I mentioned, they've been around since 1991. And as gaming has changed since then, as we all know, so is their need for infrastructure. In 2018, they went all in on AWS. And they ended up exploding with the release of Fortnite. I believe that was 2017, but it scaled up in the following years. And yeah, so one of the largest online multiplayer games, it sees over, sometimes over 15.3 million concurrent players during live events. So scale and resiliency are obviously quite important to them. And like I mentioned, they grew by more than 100 times in just 12 months. So they really needed to support peak usage more than 30 times that of non-peak, as well as the scalability to host game events with all of its users invited. And if you're thinking, 400 to 650 million, that scale definitely needed to be matched with something with high flexibility, resiliency. So they ended up leveraging tens of thousands of Amazon EC2 instances powered by Graviton processors. Fortnite runs nearly entirely on AWS, so including its worldwide game server fleet, backend services, databases, websites, processing systems. Built an entire analytics pipeline that runs on AWS that delivers insights on service health back to the developers, and massive player tournament analytics, basic user data, and game design. So they deliver Fortnite to more than 650 million players around the world. They automatically scale compute capacity to meet constant fluctuations in player demand. So like I mentioned, that's up to 30 times load during peak times, while still reducing operational costs because they're leveraging compute savings plans as well. And they saw up to 40% price performance benefits for certain workloads. And like I mentioned, with the Unreal Engine, it's not just about Fortnite running on it. They also provide a platform for game development and across industries like automotive, film, television, etc. And the senior director of engineering at Epic Games says, as we've looked to the future and building increasingly immersive and compelling experiences for players, we're excited to use AWS Graviton 3-based EC2 C7G instances. Our testing has shown they're suitable for even the most demanding latency-sensitive workloads while providing significant price performance benefits and expanding what is possible within Fortnite and any Unreal Engine created experience. So I think all three of these case studies are very exciting. But I would say this one is one of my favorites to talk about, especially with the amount of scale that comes with that online multiplayer game. So in summary, before I hand it off, Graviton-based instances provide up to 40% better price performance over comparable EC2 instances. They use up to 60% less energy than comparable EC2 instances, so really focusing on sustainability there. They power a broad spectrum of workloads: application servers, open source databases, in-memory caches, microservices, gaming servers, like I just mentioned, high-performance computing, and video encoding. Most Linux and open source applications can easily run on multiple processor architectures and are well suited for running on Graviton. We'll talk a little bit more about that in a second here when I hand it off. But like I mentioned earlier, the rule of thumb is the newer the better, or the more up to date the better, pardon me. These instances are supported by popular Linux distributions and an extensive ecosystem of ISVs. And Graviton-powered instances are available today in nearly all regions, with more regions always on the way. I constantly have to update this deck to accommodate for the amount of instances that our service team are releasing. So, all right, thank you so much.
Thank you, Shelby, for that great overview. So again, to just recap on the audience side, right? I think Graviton is a great, processor. It can save you up to 40% on the computing cost, and it's much more energy efficient. So as you can see, there are a lot of benefits to doing this. So the key question for everyone to be asking is that, okay, I see the benefit part of it, but how do I go about doing this, right? This is where we need to, Chewy Cloud is going to give you the magic sauce associated with that. So specifically, if you're going to be on the, workloads can have different characteristics. So we're trying to basically do the cost saving for the web workload. So when you do that, essentially you can do it in multiple ways. You can use Graviton using the managed services that it offers. So if you have a workload that basically has a web workload, let's say, and then your backend happens to be database, then you can actually provision your database on the Graviton processor. That's one way. Or you can use actually the managed services. And you will see in a couple slides later what are the managed services which are hosted by Graviton. So that's the one way to do that. That's the easiest way for you to do it. The second way is if you're using some business logic that is encapsulated in Lambda function, you can actually port that business logic using hosting them in the ARM processor. So all you have to do is basically choose where you want to host your Lambda function, and once you do that, essentially your Lambda function is going to be executing on the computing platform, which is Graviton. If you basically want to create a services and which backend services that gets called as part of your web application, and you're creating a Fargate cluster, which is a managed service, you basically can do that and host that on the Graviton cluster as well. I'll probably go through each one of these options in a little more detail through the next set of slides. So let's take the first one, right? What are the different managed services which are available on the Graviton? As you can see, if your web workload essentially has is using Amazon Aurora or RDS, that's the easiest choice. You can host them on the Graviton. If you have Neptune or Elasticache or MemoryDB, you can those databases are also available on the Graviton instance. If you're using OpenSearch or EMR capability on the Hadoop, then those are also available on the Graviton processor. One of the, I believe in the previous webinar I did, I showed actually a SageMaker hosted on the Graviton processor. So there's a whole bunch of options which are available where you can actually do this, use the managed services, host them in Graviton, and save about 40% of the price performance cost, essentially. Your next option happens to be Lambda function. Like I said, most of the Lambda functions are scripts, and these scripts could be implemented either in a Java, .NET, or any other JavaScripting language. All you need to do is essentially create a new function with the architecture and set that to ARM64. Once you do that, you're all set to call the Lambda function, and it'll execute in the Graviton processor. That's the easiest option. Let's take the next one. If you have a Fargate cluster hosting, let's say, either ECS or EKS, all you need to do is you're required to basically create the cluster using Graviton processor. You can also choose an image. In the next slide, I'll show you different images, or where you can actually get the images, which it could be Docker or the AMI images which are available. So you can choose an image, AMI, or you can choose and host them on the option that involves ARM64 when you basically creating the cluster. When you're creating the task, at that point, basically on the EKS or ECS, you can set the CPU architecture to ARM64 in the running, and you set that in the task definition. And when you do both of these, essentially create the cluster as well as create the task definition, at that point you are set to basically use using the Graviton processor for any of your container architecture. Last option is what I mentioned earlier. If you basically have you want images or Docker containers, these two websites offer you a wide range of choices that basically for AMI images or the Docker images, you can choose among them. The last option is if you're using infrastructure as service using EC2, and if you wanted to basically use Graviton processor, you can go into the AMI and portion of once you log into the portal, choose ARM64 as your public image filtering option. When you do that, basically you'll have a whole bunch of images that you can actually choose from for your Graviton processor. This is another way you can actually host your web application for cost-effective option for hosting. So you can do that. For example, if you have WordPress application and you have it on EC2, it's easy to move to the Graviton processor and save on the cost. This is a scale of ease of adoption. So let's say if you have if you have application that's done using, or I would say coded using Java or Python, which is more like an interpretive language, that's porting those application into the Graviton is going to be the most easiest option. You just have to basically recompile or reinterpret them into the new processor and then redeploy that. Essentially, that's the easiest option. The more difficult option happens to be where actually you need to do a recompiling for C or C++ and then redeploy the code. Now, and the last option is basically, if you have a Microsoft Windows .NET application, there are lots of videos that actually highlight about how you can actually do that. But idea would be you need to recompile your .NET core again on the Graviton processor, and then once you've done that, you're ready for deploying your code on the Graviton processor. These are the .NET versions which are supported on the Graviton processor. As you can see, the the .NET framework, the old legacy one, is not supported. But if you look at the .NET Core and the different versions or newer versions of .NET, they are supported today in the Graviton processor. If you're wondering, okay, I know how to do this, but is there anything I can use as a guidance? Will my application work on the Graviton or not? The good news for you all is that actually AWS has a tool called Porting Advisor. You can run this tool, and then essentially you can figure out if actually your application is compatible for the Graviton, or what are the issues that you will be basically faced when you're using the Graviton processor. And that tool is a porting advisor. So when you run this porting advisor and you need to run against your source code, the type of findings it'll have is basically it'll give you the things like preprocessor error. Are you using any legacy Visual C++ runtime that gives you, you need to basically take care of those kind of issues? Are there inline assembly with no corresponding ARM64 inline assembly? Those kind of issues will be pointed out, and if you basically, at least it'll give you an idea how easy or will it be for your application to be ported to Graviton. Here are the kinds of issues the porting advisor will actually detect. One thing to note here is that the porting advisor, it does not make any code changes. This is really important because of the fact that if you're skeptical about using any third-party tool, and you basically thinking, okay, it's going to make any intrusive changes to my code, you need to not to worry about it, because the code basically scans the code and the dependency, and it is supported on C++, Java, and Python and other languages. But any given time, it basically scanning the code and the dependency does not make any changes to the code. It's really important to remember that. Okay, you have done your due diligence. You're basically done your analysis using Porting Advisor. You're actually porting on the Graviton. You need to measure your performance. The good news, again, is the fact that you basically have tools, which are Linux-based tools, to actually measure the performance as you move from your traditional x86 processor to a Graviton processor. So this is these are all the tools which are again at the bottom, as you can see, performance monitoring tools, Linux performance, Linaro, Forge. All these are tools which are you can actually use them to basically measure the your performance of your application on the Graviton processor. With that, I'm going to give my time to Asif. Feel free to reach out to me if you have further questions. Asif, back to you.
Thank you. Hello. We will be discussing, as my colleagues mentioned, how you can actually, a use case where we actually migrated a customer where the real world story from his usage of Intel x86 to Graviton, and increase his efficiency and reduce his cost. The customer is providing a platform for embedded financial ecosystems targeting SMB market. It has shown a 30% increase in the last year, and as such, of course, consumption on AWS also had to increase and adapt to the financial constraints of providing the services. They wanted to incorporate a better control over their databases, specifically the RDS that they were using, and be able to reduce the cost and improve the efficiency. We encountered several factors when we were discussing this: data preservation, minimal downtime, ensuring no data loss, and no degradation of performance. Those were the key factors that the customer has indicated that he wants to give us the focus when we're doing this migration. And we had to take that into consideration when we evaluated what actions can be taken. We thought initially about right-sizing some of his performance, lesser performance tools where he was using incorrectly. Another thought was Maybe we could use commitment in order to reduce his rates for the RDS. And of course, we included the possibility of terminating resources in off hours for the development cycles. All those were incorporated in the solution. However, when we looked at the overall arch of its usage, we decided to go implementing Graviton on RDS. Why? Because Graviton, as we've heard before with my colleagues, is tailored for the cloud use. So every time that you want to use something, you might as well use the best solution available for that usage. It is meant to be chirpier than the x83, and we will discuss this in the forward slides. And it also provides fast adoption. The change in RDS from x86 to Graviton is simple and easy and fairly quick in adoption, doesn't require a lot of technical specifications. The biggest fear of the customer was the data migration fear. However, the engine, which is what the RDS is running, is not the data. The data is a separate layer, unlike when you're running bare metal where you're doing the migrations, that you have to ensure that your data also survives. In RDS, when you're changing the instance type, you're changing the engine preferences, not the storage of the data. So we were able to emphasize this to the customer, that the change to Graviton, which should be beneficial for him based on queries and on cost, will have no impact on this data, and he doesn't have to do any changes or strenuous activity to make sure that that data survives. Cost impact. This is the impact. These are the changes, or actually, this is the status of the instances the customer was using previous and the forecasted cost for the Graviton migration. You can see specifically the differences between the M5 2 extra large and the M6G 2 extra large that the customer was deploying. The differences is showing per hour. And of course, when we did provide the calculation to the customer, we also did the aggregation for the monthly cost. The customer was quite surprised to see the differences between the M5 and the M6, and also between the T and the T4G and the extra large, which were adapted based on the right sizing for his usage. The results gave the customer a reduction of 24% while increasing his efficiency, but most importantly, keeping his response time and his ability to process his request by the customers and not have any impact on his service. The performance impact actually was where the customer was mostly surprised, because the ETL jobs that he was running on x86 servers took 18 hours during the month. When we moved into Graviton, the total sum of the ETL was running 3 hours complete. So that was an 83% efficiency in moving those services and the processing to the Graviton, and the customer was most pleased. Thank you.
Thank you, Asaf, and thank you, everyone, for participating today. We are happy to answer any questions here in the chat, so you can continue in sending them. And if you want to get in touch with us and see how we can help you implement Graviton, you can feel free to scan this QR code and leave us a note. Thank you.